Okay, YouTube, this is my second video in my module on solving polynomial inequalities, in which we want to solve for the solution intervals of this particular polynomial inequality, where we want to know what are all the x values for which 2x squared would be less than or equal to negative 6x minus 1, that expression there. So basically what we're going to do is we're going to start by getting 0. Now I say loosely on the right-hand side. In this case, I would definitely get 0 on the right-hand side. In general, we would get 0 on one side of this polynomial inequality. So certainly the first thing I would check here is to see if this factors, and just to get straight to the point, this, as a matter of fact, does not factor in this problem here. But what we do notice is that this is a quadratic thing. So of course, when we're solving a polynomial inequality, what we're looking for are all of the x values for which our function is either positive or negative, or maybe even equal to 0. In this case, our y values. We want to know what are all the x values that cause our y values to be less than or equal to 0. So for this particular thing right here, we know that that can only occur, or at least if we're going to find these x values, we know that this can only occur for value or intervals of x for which our function is all positive or all negative. And our function can only go from having positive to negative y values at the zeros of this function. So what we're going to do is we're going to solve for the critical values of this. And certainly we're going to use the quadratic formula here. So we have a, b, and c respectively. A is 2, b is 6, c is 1. So we'll take a look at the zeros of this here. We have negative b, so negative 6 plus or minus, and then of course we'd have 6 squared. We have b squared, so we have 6 squared minus 4 times a. Now a is 2 times c, which is 1 here, and then we say all over 2 times a. And so simplifying this, looks like negative 6, there's our b over 2a is 4 here. And then inside our radical here, it looks like we get 36 and then minus 8. So 36 minus 8, we get, I believe that's 28 there. So we say x equals negative 6 plus or minus the square root of 28 all over 4. And I do want to simplify our square root here, or our root value. I know this is 4 times a 7. So we can take the square root of 4 here. I'll switch colors here. And we say the square root of 4 is 2. So we get x equals negative 6 plus or minus 2 times the square root of 7 all over 4. And last but not least, I know that these are all divisible by 2. So let's reduce these by a factor of 2. This would be a negative 3. This would be a 1. So we get x equals, in the end, negative 3 plus or minus the square root of 7. And I'm going to put a big box around this here. And I'm going to label this here critical values. Let's see, critical values. Now the thing here is, when we deal with something like this, it's really kind of hard to envision where this would be on a number line. Since we need to make a number line though, let's go ahead and type this into our calculators. We say negative 3, so negative key 3 plus the square root of 7. And I'm going to hit second enter to bring this back up again. I'm going to go back over here. We'll make this a minus, a subtraction sign. So we get our two zeros here that are approximately negative 0.35 and negative 5.65. So I'm going to write that down here. Purple. Approximately negative 0.35, and we also had negative 5.65-ish. And what we want to do is we want to write those up over here. So we say x equals negative 3 plus or minus the square root of 7. So we're going to write the exact values here. And maybe make a little note here. We want the exact values when it comes to reporting the zeros. But in terms of setting up our test intervals, what we're going to do is we're going to use our decimals. So I know, at least on my solution graph, I think it's always a good idea to draw the picture kind of first. But since we're all negative kind of on this one, I'm going to go 0, and then I'll go 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4. I'll get out to negative 10 here. And so we have on our number line here, we can label our critical values, and knowing that they occur at these two x values right here, I think it's okay to go ahead and draw a little arrow right here that says, you know, one of our critical values is x equals about negative 0.35, squiggly, squiggly. And our other one here is about negative 5.65. I just want to label them on the number line here, because what this is going to do is it's going to allow us to set up our test intervals now that we know our critical values. So we say our test intervals are from way out on the left, negative infinity, up to our first critical value here. And I would say that that first critical value is about negative 5.65. Now, from negative 5.65-ish, loosely here, we say to negative 0.35-ish, and then from negative 0.35-ish out to infinity, these are the values of x for which our function can be all positive or all negative. So what we're going to do is we're going to choose out some representative x values, and we call these test values. I'm going to choose negative 6 And here I'm going to choose -1. That would be very easy to plug in -1. And I'm certainly choosing 0 on this interval here. Those are easy to plug in. So what we're going to do is we're going to test our values here. So maybe I'll make a little note down here. We say the x equals -6 case. Let's go ahead and start with it. I don't want to box that. Let's do this. Let's underline it. Colon, underline. And then we'll plug this into our initial inequality. And I'm talking about this one here where we got a 0 on one side. So we would have 2 times -6 squared plus 6 times 6 times -6, it caught me off guard, plus 1 less than or equal to 0. So we have 2 times 36 plus 6 times -6, I suppose would be a -36 plus 1 is less than or equal to 0. This would be 72 minus 36 plus 1. But certainly 2 of something minus 1 of itself here would be 1 left of that thing. So 36 plus 1 less than or equal to 0. So finally we get 37 less than or equal to 0, which is totally false. And so we would say nothing in this interval here, I'm going to go ahead and cross it off, can be a solution to this polynomial inequality. So testing this middle interval here, plugging in a -1, this will be a little bit easier to do. We say x equals -1 case here. So we have 2 times -1 squared plus 6 times -1 plus 1 less than or equal to 0. So we have 2 times the -1 squared, just be 2. Here we get -6 and then plus 1. So in this case we get overwhelmingly a negative number. -4 plus 1 is -3. So we would say, okay, I guess not overwhelmingly. But relative to the other numbers, it's pretty negative compared to the other numbers. But -3 is indeed less than or equal to 0. So we say that this is true. So in terms of our intervals here, what I'm going to do is I'm going to say, well, first of all, this is a less than or equal to. And what that means is we're going to actually include these values, these boundary values in this case. And we're going to say also, because -1 is true, everything in this middle interval is true on our graph. It has to be. I kind of overshot the landing pad there. There we go. And so when we test 0 on this last one, this will be a lot quicker to test here. X equals 0. We basically get 1 is less than or equal to 0. And I'm saying that because this and this would cancel out, we get 1 is less than or equal to 0, which is false. It's not true. So in terms of solution intervals, we're going to say our solution intervals in this case are negative, and we would say this -3, whoops, I guess I can write that larger now. -3 minus the square root of 7 up to -3 plus the square root of 7 here. And just to limit confusion, underneath this I'll write it this way also. I'm going to say -5.65-ish up to -0.35-ish. Just know that what you're going to want is this one right here because it contains our exact values. Cheers.